Let's make a frequency table, a relative frequency table, and a bar graph for this data. A frequency table, we might have a label like type of transportation, and frequency. So if we look through this list of data, we see the car. We see the car represented 1, 2, 3, 4, 5, 6 times. We have a bike as a type of transportation, and the bike is 1, 2, 3 of these entries. We also have a skateboard, 1, 2 times. We have the bus, 1, 2, 3, 4, 5 times. And we have walk, 1, 2, 3, 4 times. Now, one thing we can do to make sure that we've represented every transportation type is to sum the frequency column. If we sum the entries in the frequency column, we get 5, 10, 20 entries. And if we count the number of entries in our list, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that checks out. Now, to build the relative frequency into our table, what we're looking at is our F divided by N. So 6 divided by 20, 3 divided by 20, 2 divided by 20, 5 divided by 20, and 4 divided by 20. Now, often we write this in decimal form, and sometimes we write it in percent. We have 0.3, 0.15, 0.1, maybe a 5 divided by 20 is 0.25, and 4 divided by 20 is 0.2. If we sum the relative frequency column, we should get back the sum of 1. So here we have 2, 5, 5, 5, 6, 5, 7, 8, 9, 10, which gives us 1.0. Okay, so that's another check. Now the final step would be to represent this information in a bar graph. So our bar graph will put the type of transportation on the x-axis, and we'll put the frequency on the y-axis. We'll want 1, 2, 3, 4, 5 tick marks along the x-axis, and generally we'll want them evenly spaced, equidistant. There's the 5 tick marks, right? So we can call this type of transportation. And then we can label our tick marks. We can label car on the first one, bike, skateboard, bus, and those who walk. Now on the y-axis, we'll either plot our frequency or our relative frequency. If we plot the relative frequency, then we might go by 0.05. So if we think in terms of 0.1 first, 0.2, our highest number here is a 0.3. I also give myself a space in between so I could clearly see the 0.05s. Here we'd have a 0.4. So our y-axis is our relative frequency. And now we'll put in the bars. So in terms of the car is a 0.3. So we'll go right around the tick mark for car up to the height of 0.3. And then when we draw the bike to the 0.15, our bars will not touch. So we'll have to straddle the line, the tick mark for bike, go up to the 0.15, and note that your bars do not touch. This is qualitative data. There's a quality being described, not a number. The amount of skateboarders was 0.1. So go around your skateboard tick mark to the height of 0.1 and back down. The bus riders were 0.25 of the data, 0.25. And the type of transportation for walking goes to 0.2. So in a bar graph, the bars don't touch. All right, let's construct a histogram out of the data in this table, which says that 2 people got 19 miles per gallon, 4 got 20 miles per gallon, 3 got 21 miles per gallon, 5 got 22 miles per gallon, 3 got 23 miles per gallon, 8 got 24 miles per gallon, and 3 got 25 miles per gallon. So what we'll do for this problem is we'll start with an x-axis. The x-axis will be the miles per gallon. That's our data point. We'll need a y-axis, which will be our frequency. In terms of the x-axis, we'll have 1, 2, 3, 4, 5, 6, 7 tick marks that we'll want, and we'll want them to be equally spaced. If we start our information at 19, my next tick mark on there just for fun. And now we'll also want a relative scale for our frequency axis. We have the highest frequency being an 8. So we don't want to necessarily go above 8, right? So here we have 2, 4, 6, 8. The 10 up there because it fits. Now, this time what we're going to do is we're going to allow the bars to touch. Because in a histogram, we're trying to talk about data that is numbers. So the 19 goes to the height of 2. And we'll go all the way to the middle of the space between the 19 and the 20. At the 20, our bar is going to go up to the 4, with the edge starting where the bar for the 19 stopped, and then going all the way to the middle space between the 20 and the 21. On the 21, we have a bar of height 3. The 22 goes up to the 5. At the 23, we're back to the 3. At the 24, we go all the way up to the 8. And at the 25, we're back here at the 3. So in a histogram, the bars touch because unlike qualitative data that just describes the quality, numbers can be rounded into the next number, right? It's continuous data. So in a bar graph, your bars do not touch. In a histogram, the bars do touch. Let's draw a stem and leaf plot for these two sets of data. We'll draw them on the same stem and leaf plot. The stem will be the tens place, and the leaves will be the ones digits. So let's pick ourselves a column to be the stem. And we see that we need in both cases to start at the tens. So the tens, the 20s, the 20s, the 30s, and the 40s. So the stem will be the tens data. We'll plot the information for A on the left-hand side. What we do is we write the digit that is the ones place, and we write them in order. So I've already sorted the list for us so that our numbers go in order, so that we just have to represent the 18 here in the chart. and the next 18. And we're done with the tens in list A. Now we can write our 20s out. So remember, we grow from the stem outward. So 21, 22, 22, 26, and 29. The tens digit is on the stem, and the ones digit is in the leaves. Now let's put our 30s on our list in order. I might need extra paper. Okay, so for our 30s, we have 32, 33, 34. So 32, 33, 34. One thing that we're doing is we're keeping our columns in order so that we can see information like frequency. So 37, 38, and then two 39s. I don't think it shows up, but there's a 9 there on the crease. And then we can put our 40s into place. So we have 42, 42, 42, two 43s, and a 47. So that's what list A looks like. And one thing we could do if we tip it over is we can view this like a bar graph. So we keep these in a nice column so that we can see it as a bar graph if we wanted. Now, let's put list B on the other side. Growing from the stem outward, this time more naturally, because we are used to going from left to right, increasing. So now we'll put 11, so 1, 1, 14, 1, 4, 18, 1, 8, and we're done with the tens. Right, now let's get our 20s on there. Here, I probably need the extra paper on this side. Look at all those 20s. Okay, so let's get our 20s up here. We have a 20, two 21s. You want to represent your doubles. Three 22s. 1, 2, 3. A 23. A 24. 26. And I certainly do need my extra paper. 28 and a 29. Now I can get my 30s on the list. 32, 33, 37, 38, 39, and my 47 goes down here. So if we were going to compare these two pieces of information, right, these two illustrations, then we can see there's a lot more 20s in this list, and there's a lot more larger numbers in this list. So if the goal was to get more of a change, like more weight loss, then you would choose drug A or workout program A, right? If the goal was lowering something, like lowering your blood pressure or your cholesterol level, then list B would be the better choice, right? Because those have the lower results. So depending on what it is you're looking for, a display like this can help you compare to drug results, compare to workout programs, compare things to help you make a decision.